Hello everyone, welcome back to our course. Next, we are going to introduce Elasticsearch, which is a distributed search engine. In our daily life, we tend to do various kinds of searching, like searching for a movie or a book we like on Google, or a product on Amazon or eBay websites. In this case, search engines that can give responses in real time are becoming more and more important. And Elasticsearch is just one of the famous real-time search engines. In fact, the functionality of Elasticsearch, or ES in short, is very much like Google. We can give some keywords and it returns all the relevant results. And here we can see a definition of it. So ES is a kind of high-performance, Lucene-based full-text search service. Someone may ask, what is Lucene? In fact, Lucene is just a search engine itself, but Lucene could only be deployed on a single machine, which is not enough for big data. So the developers make many Lucenes together as an entirety, and the cluster is called Elasticsearch. So Elasticsearch is a distributed search engine which is suitable for big data cases. And here we say that it uses RESTful API, which is lightweight and has good portability. Besides, it can also be used as a NoSQL database because it uses JSON objects to store data, similar to MongoDB to some extent. And to be more specific, firstly, Elasticsearch is Lucene extension. Just as we mentioned before, Elasticsearch extends Lucene so that we can deploy distributed architecture. And it also provides a richer query language than Lucene. It is configurable and scalable and has query performance optimized. Secondly, the prototype environment and production environment can be seamlessly switched. You can just connect with Elasticsearch in the same way, no matter it runs on one node or runs on a cluster containing maybe 300 nodes or even more. After that, Elasticsearch supports the horizontal scaling. It can process a huge number of events per second and automatically manage indexes and query distribution in the cluster, facilitating operations. And Elasticsearch supports structured and unstructured data such as digits, text, geographic locations, you name it. And that is why we say it can also be used as a NoSQL database as well. And Elasticsearch has many good features as follows. Firstly, high performance or high speed. The search result is displayed immediately. We implement the inverted index for full-text search. The inverted index is actually making every keyword in the document as an index. Since each piece of data itself is an index, there is no need to worry about some data not being indexed. Secondly, scalability. As we mentioned before, Elasticsearch is a distributed search engine, so horizontal scaling is supported and Elasticsearch can run on hundreds or thousands of servers. Thirdly, relevance. Elasticsearch searches for all content and finds the required information. Search results are sorted based on elements from word frequency, proximity, cost to popularity, etc. This content and functions are mixed and matched to adjust the way the results are displayed to the user. Elasticsearch can handle human errors in complex situations such as spelling errors. Last but not least, reliability. Elasticsearch detects hardware faults and network segmentation automatically for users and ensures the security and availability of the cluster. The cross-cluster replication function enables the hot backup of clusters at any time. For the application scenarios, ES can be used for log search and analysis, spatial temporal search, time sequence search, and intelligent search. So you might find it difficult to distinguish spatial temporal search and time sequence search. What is the spatial temporal data search? So spatial temporal data is data with both time and space dimensions. More than 80% of data in the real world is related to geographical locations. And spatial temporal big data includes time, space, and topic attribute information, which is highlighted with multi-source, massive data, rapid update features. And how about time sequence search? Time sequence data is the data column recorded in time sequence using the unified indicator, like the stock K lines are just a very typical time sequence data. Data in the same data column must be of the same size to ensure comparability. The time series data may be data in period of time or data at a time point. The purpose of time series analysis is to find out the statistical features and development regularity of time series in samples, build time series models, and make prediction out of samples. In short, spatial temporal search requires time and space dimensions, while time sequence search requires data to be ordered perfectly based on time series. And apart from the several scenarios we mentioned here, we can also find that Elasticsearch is applicable to these complicated data. Firstly, complex data types to be searched. For example, structured data, semi-structured data, and unstructured data. Elasticsearch can perform operations such as data cleansing, word segmentation, and inverted index creation for the preceding data types, and then provide full text search. Besides, diverse search criteria. For example, keywords and phrases are both allowed. That is, if some keywords need not to be considered separately, then you can regard them as an entirety of phrases like names. Moreover, the written data can be searched in real time. This means that there is no delay of writing and reading, thus improves the efficiency. And we need to say, Elasticsearch is in fact not a part of Hadoop ecosystem. Instead, it has its own ecosystem. From this plot, we can explore the ecosystem of Elasticsearch. The ecosystem can be divided into 3 layers, and Elasticsearch is at the middle layer, which is the data persistence and analysis layer. And the bottom layer is called the data access layer, which includes 2 components. One is called logstash, and the other is called bits. So the logstash is a real-time data transmission pipeline for log processing. It transmits data from the input end to the output end and provides powerful filters to meet personalized requirements. And Bits is a platform dedicated to data transmission as well. It can seamlessly transmit data to Logstash or Elasticsearch from hundreds or thousands of computers. And the top layer called user access layer and Kibana plays a vital role. So Kibana is a kind of open source analysis and visualization platform for data on Elasticsearch. You can obtain results required for upper layer analysis and visualization. Developers or O&M personnel can easily perform advanced data analysis and view data in charts, tables, and maps. So you might be curious, what is the relationship between Elasticsearch ecosystem and Hadoop ecosystem? Here, in fact, we can use some plugins to connect Elasticsearch together with Hadoop, and then we can use Spark or Flink to analyze data and use Elasticsearch for real-time searching of the results. And finally, let's have a look at the Elasticsearch system architecture. Just as other components in big data, distributed deployment is one of the advantages of Elasticsearch as well. This figure describes the distributed cluster architecture of Elasticsearch. In a distributed system, multiple Elasticsearch instances can form a cluster. One cluster contains multiple nodes, one of which is the master node. Yes, that's right. Elasticsearch also follows the master and the slave architecture. So you can find that master and slave architecture is so important in big data platform, right? And in this cluster, the master node is called ES master. This master node temporarily manages cluster level changes such as creating or deleting indices and scaling up or down cluster sizes. Meanwhile, ES node can be seen as the slave node. And in this graph, you can find 9 ES nodes. But unlike HDFS or HBase, Elasticsearch is decentralized, which means that the master node is dynamically elected and thus there is no existing single point of failure. In the same subnet, you only need to set the same cluster name on each node. Elasticsearch will automatically combine the nodes with the same cluster name into a cluster. It automatically manages communication between nodes and data distribution and balancing between nodes. Externally, Elasticsearch is an entirety. Besides, you may have found that in ES, we can also define shards and replicas. Like many databases, Elasticsearch splits a complete data file into multiple shards and distributes them on different nodes, and thus improves the throughput. After that, Elasticsearch allows you to set multiple replicas for each data file. Replicas can improve the fault tolerance of the system. When a shard on a node is damaged or lost, the data can be recovered from the replicas. In addition, replicas can improve the search efficiency of Elasticsearch by automatically balancing the load of search requests. Alright, and that's all for this chapter. In this chapter, we introduced what is Elasticsearch, some features and application scenarios of it, the Elasticsearch ecosystem, and system architecture of it. Hope you guys enjoy all the contents in this chapter, and see you in the next chapter.